Howdy folks. Today we have a very unfortunate repair. It's a Marshall JTM30 and you can see the power transformer is missing, and that's because it's lived up to its name. Doesn't take a genius to see what that looks like. And if I bring it around this side, you can see the beautiful melted plastic. And if I lift the bell housing off it, you can see more of this delicious goo, all nicely melted. And we can look inside the bell housing here, and you can see the insulation, the enamel off the copper wires is definitely melted off there. But the good news is, brand new Hammond transformer. In case you're wondering what the exact model is, it's a Hammond made in Canada. That's nice. 290QX. Okay, and it's got all the correct pinouts to give you the right voltages. Okay, and tells you what they are here. Pin 2 and 3 are 120 volt, and pin 5 and 6 are 120 volt. Now what you do, here's 2 and 3 and 5 and 6 up the top here, is your AC goes to pin 2 and pin 6, and then you bridge pin 5 and pin 3. Just like in the actual transformer, the original OEM transformer. Now if we look here, pin 9 and 10 are the 325. So 9 and 10 on the right hand side here. That's our high voltage that goes to our plates, or goes to our output transformer and then our plates. Okay. What else we got here? Pin 11 and 12 are our 6.3 volt. So 11 and 12 are our heaters. Okay. And then we have 13 and 14, which are our 25 volt. All right. So I'm going to fit this into the amp, and then I'm going to show you what wires go where and what we connect up to where. Ah dear. Well, here's our first problem we run into. This is supposed to be a drop-in transformer, and that's how Hammond advertises it. And this is a JTM30. It's a JTM30, if you can read that upside down. The holes don't line up. So I can get these two in, and even if I try to like pull them back out a bit to help line up this side, you can see that one's almost in. That one's not even close. So I'm gonna have to either undo these. So what I'll do, let me do this one-handed. I might undo these screws on the transformer and see if there's a bit of wiggle room. Hopefully the iron hopefully has holes that are a little bit bigger and they can kind of be pushed and pulled around a bit. And then if that doesn't work, then we're gonna have to drill out these holes a little bit, which, you know, there's not much meat there. It's pretty close to that opening on the chassis, and I'm hoping, oops, let's get focus there. I'm hoping I don't have to drill out the holes. Drop-in transformer, my butt. Alright, ladies and gentlemen, this is the new transformer fully installed. I'm not going to put my fingers in there right now. The amp isn't live, but it is on standby, and I wanted to plug everything in and test it out because I wanted to check A, that the wiring is correct, and B, that, you know, the amp didn't go up in smoke again. So I'm kind of going to let it sit here on standby for a bit. Now I don't have any power tubes in here, and I'm not going to until later. Right now though, I just want to get this thing warming up nicely, sitting here and soak testing. I'm going to be watching this power transformer for a bit. I know it's brand new, you know, but I like to test things out. And then I'm just going to probe this with my multimeter and just check some voltages. Now, I can see the heaters are on because I did leave the preamp tubes plugged in. Okay, I just haven't got the power amp tubes plugged in. The 588 ones that are sitting here, I've got them out. So, you know, what I'm going to do though is just in case those power tubes are faulty, or who knows. All right, what I'm going to do is I'm just going to let this amp sit here I'm going to let it soak. I'm going to let it just do its thing. And then I'm going to measure voltages. All right, folks, so I got everything hooked up. I've got the amp turned on. Now I have checked over voltages. What I did, and I didn't show on camera, sorry about that. Before I put the tubes in, I stuck my multimeter into pin 3 on each side to make sure I was getting plate voltages. And I'm getting a lot less than what I expected, which is great. That's going to help with lowering the bias, and it just tells me that this power transformer is working properly. I was getting about 437 volts on either side. So it's a push-pull, so you're getting pin 3, 437 volts on this one and on that valve. So both valves or tubes, whatever country you come from. Now, the amp is on right now. It's in standby mode, so I'm just letting it warm up again. I have done a bias calculation already. It seems like it's running fantastically cool in comparison to the last video you guys might have seen of this. And I've also hooked up a oscilloscope to check out what the waveform looks like as well. So first thing I'm going to do is I'm going to show you what the bias looks like. For now, I'm just going to flick the amp on, and I'm going to let it sit here and really soak test and warm up. And while it's doing that, I'm also going to be glancing back at this and making sure there's no red plating or anything's running away. I'm also going to measure the bias. Now, I've gone ahead and modded this amp, and I've changed the Zener diodes in here, so it's running the amp a lot colder than what it should be by default. And you know, I'm starting to form an opinion on these amplifiers. I reckon the bias circuit in these has always been fine. That minus, what is it, minus 39 volts according to spec? Hang on, let's go have a look at the diagram here. Let's see, bias circuit. Yeah, these Zener diodes, so you got a 9, a 15, a 15, so 39, yeah, 39. So what should be happening is you should be getting a negative voltage of negative 39. So I'm just coming back to the amp here because I've got it switched on and going, and I'm really paying attention to those power tubes and making sure there's no red plating. Based on what I've biased them at, it doesn't look like that. So I thought I'd run them a little bit colder than what they should be, and in fact what I'm going to do, I'll show you what I'm talking about here, and then I'm going to turn this off, let it cool down, and then I'm going to flick the tubes around, and then I'm going to measure the bias again. Okay, so I'll leave that running for now and just let it do its thing. So coming over here, now let me go to my bias calculator. Now what I've got is I measured the resistance on either side of the output transformer, and I got dyslexia, 71.3 ohms on one side and 71.8 ohms on the other side. When I measure the voltage drop across that same point, I get 3.08 volts DC voltage drop, and on the other side I get 3.03 volts DC voltage drop. So what that gives me is it gives me a very uneven plate dissipation. So this is in watts. Okay, if I'm getting ahead of myself. Let's go down here for a second, and what I'm getting is a plate current of 32.1 milliamp, and on this side I'm getting a plate current of 25 let's call it 25.3 milliamps. If I convert that to wattage, I'm getting 16 watts on one side and 12.9, so or 16.5 watts on one side and 12 on the other. Now if I go up here, okay, 70% is 16.1 for my 5881s. So that's gone a bit over 65.8. I think there's something wrong with my maths there. And 51 on the other side. I'm going to have to actually look at my, I think that might be rounding. What's going on there? E6, which is 23 times 0.7. But you get the idea there. Now coming back to the amplifier, this has been switched on for a few minutes now and in play mode. So standby switch is on, which means, or off, depending on your point of view, which means it's in play mode. So I've got a signal generator running. So I'm going to cut down here to my oscilloscope, and I'm just going to run my, don't worry about the little, the waveform there messing up. That's just my oscilloscope not syncing. And if I just turn that gain down slightly, there we go, I might be able to see the breakup of those tubes there. So it's pretty clean, and then you can see it's starting to deform there, which is well past halfway on the input, and then that's the output. So that's the master volume I'm messing around with there. Got that turned down again, and that's the input. So you can actually see the distortion of the different sides of, you can see valve preamp distortion on the clean channel, and you can see, if I clean that up, it's power amp distortion. Alright, so it turns out my spreadsheet was right along. I used Google spreadsheets, and for some reason I noticed there was a bar up here that was continuously progressing, and the page was continuously loading, so the calculations weren't working. However, looking down here, we can actually see it's still biased hotter than it should be. We've got 75.5 on one side and 73.76 on the other. The good thing about this is, okay, it's just over 70%. That's a bad thing. The good thing is the tubes are closer matched. Now, I still have swapped them around anyway, so I'm going to redo the bias calculations and see what we get this time. See if the differences in the resistance on each side of the transformer make a difference. But let's do that now, and I'll get back to you in a moment. Alrighty, so I've done another calculation, and yeah, the valves are just barely kissing 70%. They're just over it. But you can see now that I flick the tubes around, okay, so a couple of things to notice. Obviously the resistance on either side of the output transformer is still exactly the same. The voltage drop has changed slightly. It went from 3.08 and 3.0, what was it, 3 or 5, down to 2.93 and 3. So that's changed. And then that's also changed the wattage. So we can see that plate dissipation on one side is 17.87, let's call it 17.9. And on this side it's 18.17, let's call it 18.2. You can see from my last measurement, and this is usually a typical thing, the voltage has also dropped on the plates as well. It went from, what was it before, 438 volts, down to 435. The main reason for that is it's kind of home time, and a lot of people are coming home right now, so guess what? The mains voltage drops down a little bit. So what we get from our calculations though is a slight difference, and it's a little bit nicer, and also swapping the tubes around brought them closer together as well, mainly because of the balance of the resistance up here. So what we're getting is a plate current of 41 milliamps on this side and 41.7 milliamps on that side. Doesn't sound like a great deal until you get down here and look at the percentages. 71.5, 72.7. We're really only off by 1.2%. You know what? That's perfectly fine by me, and it's close enough to 70% because, as everyone knows, these amps are a bitch to rebias. That's good enough for me, and considering I changed the Zener diodes up in here, which is probably getting too dark to see now, the Zener diodes in here have been changed. I'm happy to keep them at that minus 41 volts because that's keeping this in check. And if anything, I would probably even go further to try to reduce this down to 65% if I was going to bother with it. To be honest, looking at the valves, they're not red plating. The amp is fully switched on. There's the standby switch. That is completely on. And I can also show you with the ending of this video and the helicopter flying overhead. There's our waveform there. Oops, wrong channel. So there we go. That's all working nicely. And I'll try to, let me see if I can sync this up a bit better. There's our output distortion. And here's our input distortion. So let me try to get this in sync a bit better, hey? What do you think? That's probably a bit nicer. Okay. And you can hear that coming through, all right, through the resistors here that I have set up in 16 ohms. So there you have it, guys. Now it's getting pretty dark in here, so it's easier to see if there is any red plating, and I see none. So pretty happy with that. I'm done testing that. Next thing I'm going to do is put this all back in the chassis, hook it up to the speaker, play it for a little bit, and then soak test it in the cabinet, you know, in situ, let it heat up, let it do its thing. I'm also going to keep my hand every now and then. I'm gonna touch the power transformer. It's getting warm, but it's not getting hot like the other one was. And I'll bring up a photo of what it looked like when the customer messaged me saying, "Help! His amp blew up," and it went up in a puff of smoke. So there you have it, guys. How to change the power transformer in your 240 volt JTM30. It's running cooler, it's running nicer. The bias is much better than it was before. And yeah, thanks for watching.